All right, so hey guys, I'm Tony, and I'll be talking about Twitch in our GraphQL transformation. My full name is Tony Ghita, and it also happens to be my handle on like every single website on the internet. So follow me on GitHub, Twitch, and Twitter using that handle. If you want like any more information to stalk me any further, just check the Equifax dump. You'll find my social security number. I'm an engineer at Twitch on the API platform team, and I've been leading the GraphQL API implementation efforts for the past year or so. Before we get started, I noticed some of the other speakers yesterday shared some pictures of their pets. So before we start, I'd like to share some pictures of my teenage puppy, Finn. So this is Finn. Sometimes he's mischievous. He threw his ball in the toilet. I don't know why. He wanted me to like play with him or something. But mostly he's a really good boy. So I guess I don't really wrestle bears. I thought I would put that like line in my intro and it would go into some box and no one would ever see it. So apologies, Lee, that you had to read that terrible joke. But if there was ever a bear that I was wrestling, it'd probably be this guy. All right, so back to our regularly scheduled programming, Twitch in our GraphQL transformation. So for those of you who are not familiar with Twitch, it is a social video platform for gamers. And it looks something like this. So this is Twitch, and it's also our newest web app. And we're actually right now in the process of ramping up traffic to this app as I speak. And we hope to be serving it to 90% of logged in users by the end of tomorrow. And the novel thing about this is all powered by our GraphQL API. It's written in TypeScript, it uses Apollo client, and it's written in React. I think probably the most remarkable thing about this is that it's been completely rewritten in over just the past 6 months, so basically no time. So how do we get Twitch on GraphQL? Well, it required a pretty big paradigm shift on our part. So for a lot of us, REST has been synonymous with APIs for the entire length of our careers. So going from a well-known get users, friends, to this query here is not so straightforward. We had to start thinking in terms of data and relationships between the data instead of endpoints. But as we went through this process, we found it was like adding a missing unit test to our overall systems. So the new perspective changed how we thought about aspects of our service-oriented architecture. So just adding a different API that totally didn't adhere to any of the standards just completely blew our minds. So through the whole process, we ended up with much improved services. So Sashka actually just talked about this, about putting the right things in the right places. And I think that extends beyond client and server. And we found that it extends to like the API gateway and also the services behind there as well. I think that's a little bit unexpected. But yeah, so I'm hoping to share with you our journey to adopt GraphQL, and I'll share also some things I wish I knew when I was starting out. And I hope this encourages you to start your own journey if you haven't already, or to continue if you already have. So at Twitch, we have about 600 engineers. I'm one of the nerds. And we've had massive growth over the past year, so something like 2x the engineers. So lots of new faces. I'm one of them. Our architecture looks like this. I work on the API gateway team. That's the API gateway. It takes requests come in from the internet. It goes to the endpoint you've asked for, and it fishes out all the requests to the backend services. So hopefully this looks pretty familiar to you. We have over 100 of these microservices. It's a little bit crazy. It's just kind of like a soup of services. And we have a pretty massive monolith, although it's shrinking as we migrate away from it. So hopefully this sounds like kind of a familiar architecture to you, and hopefully you can relate. Our services are actually written in Go, so that's where our GraphQL API would come to live as well. So I haven't heard too much of that, but hopefully there's some Gophers out here. The Gophers are actually Go's mascot, so I think it's probably one of the coolest part of the languages. So most of our services are also written in Go, so they kind of look like that. They're all Gophers, but they look kind of different. But everything speaks REST and JSON. So, I mean, I imagine most companies have been implementing this as their API for the last decade or so. So here's a rough timeline of the steps we took to build the GraphQL API. We actually started at GraphQL Summit 2016. And we came to GraphQL Summit knowing next to nothing. And we're about to throw all our API traffic on GraphQL like by tomorrow. So that's kind of scary, but I'm going to take you along the steps we took to get there and what I learned along the way. So this is actually GraphQL Summit last year. So we came here and we were like, man, this GraphQL thing sounds kind of cool, but I don't really know anything about it. And we just really took time to like marinate in the ideas that were coming out of this talk. And we realized that GraphQL solved many of the issues we were experiencing at the API gateway level. So things like versioning APIs or endpoints overfetching data or just even providing a good developer experience were things that we really cared about, and we're pleased to see that GraphQL really provided a nice solution. And we came away from the summit with all sorts of ideas about how we could use GraphQL to make our lives as API gateway engineers better. So we set out to build a proof of concept shortly after the summit, and our best idea at the time was wrapping our existing, or creating REST endpoints from GraphQL. So we would use GraphQL on the backend to hydrate all the data needed for REST endpoints, but we'd still expose the REST endpoints to our consumers. So that sounded like a pretty good idea, because we had a lot of work to do migrating out of the monolith and to our API gateway. But that was kind of like just building a faster horse, where this is like a famous quote, misattributed to Henry Ford, but the gist of it is like if Henry Ford had asked his customers if they should build like what he should build, they'd probably tell him they want a faster horse rather than a car. And in this case, we definitely started off looking for a faster horse instead of a car. But anyway, we started on a prototype, and it was the most simple thing I could think of, just like a single type with some fields and a query to get that type back. Nothing complex, just fetching data from a single service. And this was enough to kind of really get our feet wet. So we learned how to resolve types and fields, also how to load data efficiently. So we added this query, which allowed you to look up users by IDs and by names. So if you ask for the same user, like if an ID and a name points to the same user, you should only load it once. So, and it taught us like how you integrate a service. Even though it was just a single service, it was still kind of, at the summit last year, it was kind of this nebulous concept. So it was really nice to just get it done and really understand that it's not magic, and it's actually pretty straightforward. So the proof of concept was pretty promising. We're like, all right, cool. What else can this do? Let's see how types get composed together. Maybe it can help us hydrate our data for our REST endpoints. So I took some baby steps and came up with a plan to implement our logged out front page in GraphQL. So I took as Dan Schaefer mentioned, I took a client-driven approach and looked at like, what is the data I need here? Looks like we need some streams. We also need to fetch some games, like their cover art and how many people are viewing at the time, the name of the game. And if you squint real hard, you probably can't see it. But streams also has some information about like users and the games that are being streamed. So this actually turned out to be still fairly simple. Obviously, this is simplified for the slide, but the gist of it is right here. So you have a user, you have a stream, you have games, and you have ways to get those three objects. And you can see inside the stream we have a broadcaster, which is a user, and a game, and so on. So through this exercise, we learned how to compose types. And also, it was our first foray into doing pagination in GraphQL, which I think is a little non-obvious at first. So type composition was pretty straightforward. You just return the other type. You only have to make a type once, and then you can compose it anywhere you want in your schema. That's awesome. But once we had to put pagination in the schema, we really had not a good way to know like how to proceed. Our backend services did pagination in all sorts of different ways. So some did offset limit, some did cursors, some had some of this weird timestamp offset pagination. It's kind of all over the place, and this manifested itself in our REST APIs. So we had this like nebulous nest of different ways of doing things. So as an API consumer, that wasn't super nice. And as someone making a GraphQL API, I didn't want to make the same mistakes again. So GraphQL actually made a really nice place to add a translation layer to use cursors for pagination. And it didn't matter if the service underneath was using offset limit or some timestamps or whatever it could. We could use GraphQL as a translation layer to just expose this very standard interface of cursors. So the query looks something like this. So let's say we're going through games. You can specify just get the first 10 after A01 S4. And then you can get some data on there. And you can go on and on, paginating through the cursors that you get back on the edges. And if you're not familiar with this, I'm actually going to get to it in a second. But we found the specification put out by Relay and really latched onto it as like the way to make pagination really nice. I'm not going to go too much into like the Relay pagination method, but I think the big takeaway from this step was that you can use GraphQL as your translation layer from your clients to your backend services and really standardize the interface. And this is awesome. You don't have to like check documentation like, oh man, I'm trying to get streams, like how do I get the next one? You can kind of just assume it's going to work in a certain way. And pagination is only one example of where we saw this kind of opportunity to standardize our API. We'd eventually see this standardization kind of work its way down to the backend as well. So now that we're doing cursors everywhere, backend services are also like, oh yeah, but hey, we should probably take that standard as well. And GraphQL gives you a good kind of buffer layer to not expose clients to those changes and also to be able to make those changes freely on the backend. I do want to point to the Relay cursor connection spec, though, because I think it's really good. And if you haven't read it, I encourage you to do so. It's pretty short and succinct. So there's a short link to it. OK, cool. So we're progressing along in our prototype pretty well by now. But we've really punted on what to do for auth. I kind of had an idea that it wouldn't work well with our current auth system. But we're at the point where we couldn't, if we wanted to use GraphQL, we couldn't like punt on it any longer. So time to face the challenge head on. Auth. OK, so when we talk about auth, we really mean authentication, like who's making the request, and authorization, which is what is the authenticated user allowed to do or see. So this is our familiar API gateway to microservices architecture. Again, requests flow through the API gateway first, and then endpoints aggregate data from any backend services. The way authentication and authorization work here is every request is authenticated as it comes in, and then when it reaches the endpoint, every endpoint knows what data it needs to get from other services, so we just do authorization there. And we did it this way to make it easy for service owners to not have to worry about too much when they're exposing data. So we were like, hey, we're the API gateway team. We'll take care of it for you. Don't worry about it. Yeah, so we get authorization tokens and send them to the services. And then the services can know, like, OK, this request is authenticated. Here's your data. Or conversely, like, bounce you out. And we don't even go to services at that time. OK, but in GraphQL, that doesn't really map extremely well. You only have one endpoint, first of all, and the queries are not static anymore. Anyone can request any kind of data that will hit any amount of backend services. So what do we do? We thought about just taking a first pass over and kind of analyzing what are the authorization needs. But that seemed kind of complicated. And once we got like the token for that, and say we had a massive amount of authorization logic that needed to happen, would we pass that token to every single service? Like, not every service would care about that information. And it seemed kind of strange. OK, that's fine. We could try to make it so that every resolver calls the authorization service as needed, and then maybe merge the tokens together to send them a service. But I don't know. It seemed kind of weird too. Like, it didn't really fit. It didn't really feel good. So we thought pretty hard about it, and then asked around some other people how they did it. And I think it was actually Dan Schaefer. I don't know if he's still here, but he's like, hey, check out my talk. So we did. And I'll link to this talk later, but the essence of it is basically push authorization below the API layer. Just like get it out. Like that's not the right place for it in GraphQL. And I think it's also not the right place for it in REST as well, but it wasn't as apparent because it kind of just worked then. This actually greatly simplifies API development. You're just passing data back and forth now. So as Dan Schaefer says, keep the API layer thin. So this really enforced a good separation of concerns. And it's not something that we would have came if we were just like kept adding REST endpoints. OK, and I kind of made it look easy. Like we just kind of moved a box out of the GraphQL layer and into the service layer. But it was actually super hard to convince all these tens of teams that they need to now consider all this authorization business logic in their service. But it really feels like the right thing to do, and I think we all kind of came to an agreement that we'll be better off for it. And I think the end result will be way better than otherwise. So if I can wrap that up, and kind of the takeaway there is I think keep it simple. So that may not be the right approach for you. It may be actually more complicated for you to do it that way. But don't make it more complicated than you can afford, I guess. So if you have logical abstractions like a gateway and then services, use them. And maybe if you don't, but you're growing, consider planning to make those layers. So keep the API layer as thin as possible, and allow services domain over their own business logic so they can change it as fit. And the API doesn't need to know about it. Here's a link to Dan Schaefer's talk. I highly recommend you watch this. It's really good, and that's where these ideas came from. OK, so we kind of figured out most of the nuts and bolts. So at this point, we were kind of like shopping around our prototype to teams and showing the potential of it. Like we were loading all the front page, like logged out, logged in, and those are pages that took tens of REST requests to load. And now we were just loading it in a single GraphQL request. So it became really obvious at this point that GraphQL was something that we could really, really benefit from. And we were lucky to catch our clients team at the start of a rewrite. So they sought out to like modernize their stack and kind of sort things out in the right way for them. And they caught on to this GraphQL thing, and excuse me, all of a sudden it went from just me contributing to GraphQL to like everyone. And this really caught me off guard. So we got lucky in finding support, and I'm so thankful for this because it really kicked off our whole movement. But suddenly we had a bunch of contributions to the API from all over the company, and I just wasn't able to keep up. So while the prototype was like super effective, I want to try to give you some tips on like what I wish I knew before, so you can anticipate the success and maybe you have a better time than I did. So I forgot who I was talking about this, but it's largely like impossible to give good advice about specific implementations on the back end of GraphQL. Like there's some things that come out, but I think there's so many trade-offs that you have to make that largely depend on like the scale you operate and the technological choices that you made that it's not always clear like what works for one company may not work for another. So when you find practices that are good for you in your implementation, document them and really be aggressive about this. and explain why you're taking the current approach so that when the next developer picks it up and they also have no idea about GraphQL, it's a little bit less of a shock for them. And they'll have a great reference to work off of and won't be so lost. And kind of in the same vein, when you find something that works for your schema and for your data, write it down in a style guide and iterate on it. So we're continuously working on ours as we find things that work and things that don't. They break down in certain situations. But I think it's super invaluable to have one. And I wish I would have started writing one earlier. From the style guide and from the documentation, you can start to write linters. And this kind of automates the effort of enforcing the style guide and kind of takes away the need for the mechanical feedback and pull requests that you may get from onboarding new developers into contributing to your GraphQL code base. And it helps new developers get up to speed without really requiring them to ask you, hey, is this OK? You can just say, run the linter. Fight boilerplate. So I think this may be a little bit more a function of the language we use. So we use Go on the back end, like I mentioned. And it seems like, from my experience, there's a lot of boilerplate involved in getting some types working in the API. And that looks like this. So that's our user type that we introduced a couple slides back. It's got an ID and our name. And the way that translates in our implementation is we make a user resolver struct, and then that user resolver struct has methods on it that map directly to those names. So you can see here, all it's really doing is like loading the user, checking some errors or if it's not there, and then just returning a value. So that's pretty boring stuff, and you don't really want to get into the business of writing that. So Go comes to our rescue here, and it's actually really easy to generate code in Go. So that's what we do. And I encourage you to do the same in your implementation. Maybe even if there's not so much boilerplate involved, but just to kind of enforce standards or to like give your developers a good set of rails to ride on, so to speak. Right now, we're just generating our resolver kind of schema. So pretty much everything but the last like return value, where we have to know what the schema field maps to at the service layer, at the model layer. That like last line is the only one we need to really write. Our backends are kind of nebulous and they're not really standardized, but as they move towards that way and as they maybe implement like IDLs like gRPC or protobuf or thrift or whatever it may be, the dream is to kind of tie that to the GraphQL schema and then generate the full thing front to back. So essentially requiring teams not to code anything in the API layer. So I'm going to make maybe a bold statement claiming that GraphQL knowledge share to your colleagues is probably an order of magnitude harder than any of the technical challenges in building an API. So be really aggressive about automating that knowledge share. That's something I really hadn't considered, but I think would have made a big difference in getting us up to speed. And this kind of makes me think of a quote that maybe you've heard before, but it goes, if you want to go fast, go alone. And if you want to go far, go together. And I think that's super valid here. Like we were able to iterate really fast, just like me working on a prototype, but I can't like rewrite Twitch myself. So if you do want to see the rewritten website, I encourage you to check it out on go.twitch.tv and compare it with the experience on old Twitch. There's like a beta flag you can select to go back to the old version. I hope you find that it loads like much faster and it's just a nicer experience in general. I think I have one more minute, so I'm going to power through this. I have some bonus slides that didn't really fit on my like prototype timeline, but I wish I knew this before I started as well. So with respect to nullability, I made a pretty subtle mistake in our early prototype that propagated to our current application. And you can see here we have the user query with a nullable user type returned. And the query at the top is specifically designed to demonstrate this nullability fail. So we asked for a user that does not exist. And the way we've implemented our API now, which lazily loads the user until the field is resolved. So the thought was like, hey, we probably don't need to make the extra lookup. If the ID is good, we just pass it to the next service, and we're good. We've optimized the calls awesomely. But this is really not the response we want at all. It should actually look more like this. So this has caused us a bunch of headaches on the client side, because now you can't really trust what the schema is telling you. So if I can give you any advice, is don't prematurely optimize and load data at the node level. And for errors, do the minimum to make errors useful, and assume that no one will really look at them. So be lazy about it. But you do want to assume that people will just throw away the entire response if you give back errors. But maybe be nice to clients that want to do more sophisticated behavior around that, and give them enough information, like where the path to the error occurring, or maybe like just some simple code that you can use to translate. For mutations specifically in errors, there's a special case, I think, that are validation errors, and those should probably go on the payload, the mutation payload. Reserve the errors for the bottom level errors array for service type issues where you're comfortable throwing just the entire response away. There's a good article on designing mutations that talks about like payloads and inputs and stuff like that. So I encourage you to check that out. So who knows what's next? I'm not really sure. Maybe we'll add subscriptions or something. I don't really know. I'm looking forward to just reveling in the success. So thanks, guys, for listening. I hope it encourages you to continue your journey or start it wherever you may be. But thanks.